Hi, my name is Dan, and this video is one of the very last videos in quite a long series of videos, which are charting the progress of creating a simulated 4-bit CPU that is programmable and has been created out of components which in turn have been created from the basic logic gates that hopefully you know something about if you're coming and looking at this video. We're very late on in the progress now. We're nearly got to the end, and we've built the CPU out of various components, and we're about to add some manual controls to be able to run. And in fact, we're going to make use of the halt command output from the control unit as well to make sure things go as they should do. We've got manual data entry in, we've got everything else in that we want, it's just the controls now. So there is a roadmap of where we've been in the description down below. If you're just dipping in at this point, there's a whole lot of stuff that might not make sense to you, depending on your prior knowledge and yeah, whatever. Everything's now quite specific because it's a specific CPU design that we're using. That had to become the case at some point. Some of the earlier videos in the series are much more generic and generically usable. But while you're going to get some general principles out of this video, if you're just dipping in without having seen stuff before, there might be things that don't actually completely make sense to you. Did I say there's a roadmap down in the description below? If I didn't, I just said it. And there's also a link to the software that I'm using, which is DigitalWorks, which is digital electronics simulation software, which allows you to put together all sorts of things. It has built in a whole load of parts that you can put in, but actually in this set of videos, we have built all our own parts from scratch, pretty much. And I hope, if you've been playing along with me, that you've gained quite a strong understanding of what's needed in the CPU as a result. That is the kind of the point of doing this. So let's get into it. We want some controls, and let's quickly think about what we're actually going to want. We've got a go control down here, which is where we actually start the cycle of things going. But we've got a halt control line coming out of the control unit, and we want that halt to be able to do something, to be able to actually stop the process of the PC going. So that's fairly straightforward. We also want to be able to reset all of these registers so that they're hold 0, 0, 0, 0. And that's straightforward because all of them have got a clear in them. And then we also want to be able to do a full clear, which will basically clear out the memory banks as well, so that any data that's in there can be written to be all zeros. And what we're going to do is we'll do the reset first, and then the clear will do the reset as well. And we'll wire it up so that the clear does the memory banks and everything else that we've asked clear to do. So let's deal with the go thing first, which is the operator. And in fact, what we're going to do in order to make this effectively switch on and then keep running, and then switch off when we want it to, is that we're going to combine a manual control here with the output from an SR latch. So I'm going to take away that control, and we're going to combine these two together using an AND gates, which I'm going to stretch out there. So one side of this is going to be the manual control. The other side of this is going to be when we hit reset, it will also set this SR latch as well. And we don't want it as a flip-flop, we want the actual latch. It's bistable. I hope you saw the video in which we created this. That feels like a long time ago now. And we're going to use the Q output. In fact, we're going to chuck this onto its side in order to make that useful. Let's kind of line it up. Okay. So set for this is going to be part of our reset process. And we're going to put a control in here. I'm going to call that run. Because this is important, we're going to make it extra big. There we go. And in fact, if we want to pause execution, we can just switch that off and not do a reset, and then switch it back on again, and it should continue from where we've been. So as I said, I'm going to put set as part of the reset process, but the part of the point of having this latch is that this then can make use of halt. And what I'm going to do is I'm going to wire out of halt into R, which is going to reset, so that'll switch that off. And as soon as that's switched off, it means that this line becomes low, becomes 0, and so the process will stop at that point, which is quite a useful thing to happen. And we're going to go right to the bottom to whip that wire around. So that's going to reset. There we go. So as promised, we're going to want a reset line. And in fact, because we want to also be able to control this from the full clear, we're going to chuck in an OR gate for that. I'm just trying to think where I'm going to put this functionality. We're going to want to get to the clear for everything, which is going to be quite a challenge because we've got so many wires around now. It would make sense for these controls to be over here. Got a bit of a space here, but I'm intending to put, why don't I put it in now? I'm intending to put in the opcodes in there. We've got a macro, or I have a macro that I created. I didn't actually walk through the process in the videos, which just tell us what the opcodes are. And it probably would be useful to have those written in here so that we can have a look at them if we want to be programming. So that does actually give me a reasonable amount of space here. So I'm going to use this space here in order to create the reset and the clear. So I'm going to need two lines, one of which is just going to go to the memory banks to do a clear, and one of which needs to go to everything else to do a clear. And I'm just looking at the memory banks and where the clear is, and there's a clear there. I think I'm going to try and squeak that through here. So we'll do this bit first. This is where we're having so many issues with so many wires going on at once. I'm going to be able to tap down to that if I'm careful and I can get the right place. But will this go all the way across? Kind of. All right, I'll do that. And I haven't got anything to connect it to yet. So that was maybe a mistake. What am I actually going to do in that case? I'm going to delete it. And let's have control. And in fact, let's have two because I want the reset as well. Actually, we're going to need an OR gate. Where I'm going to wire this up is that. um, squeeze that up a bit, is that so the actual reset stuff is going to come from the outputs of this OR gate. That's the reset control. So if I hit that, that will do the reset. And the clear will also come into here, but it will also do those extra things that I was working towards up here. So let's try this again with our squeaking of our wire there. And we just, ooh, I've made that slightly higher, but in a different place. So tell you what, I'm going to do a bit more in terms of corners. I'm going to bring it through here instead. I'm a little happier about that, to be honest. And that's coming to the full clear, which is here. Let's put a couple of annotations in. Let's call this full clear because I've just called that. And this one I'm going to call reset. So now the output from here needs to go to clear for every single register. And reset for the ring sequencer. And set for this. Okay, so let's bring a wire around this way first. I'll just do a little chink out there. And come down to the set of that latch. That clear comes through. And we want this reset to connect as well. I could go around, but I could also equally well just go up there to connect that. We want clear for this one. Again, starting to compound corners here. Connect that up. Slightly off where I thought the joint might be. Never mind. Does the control unit need a clear? No. Ring sequencer's got it. Program counter's got it. Our go stop latch has got it. Does the ALU need it? Yes. The memory banks don't need it. So I'm given the op register it. So it's just these registers and the ALU that need it. And the reason why I'm thinking about this is because I'm trying to work out how I'm going to get stuff in. What I'm actually going to do is I'm going to create a wire that I hope will be able to sneak down through a gap here. There we go. And this is going to the clear down here. I'm going to connect all these up because all these are just now on the right hand side, and I should be able to just connect them across. Don't want the memory bank. I've got that. And then the final one of these is from the ALU, which I'm going to sneak in that gap there. And then somehow I need to connect around from this or this here to that. And I'm going to use the bottom end a bit further than maybe you think you need because of that. How far around am I going to go? Actually, let's connect through here because that's part of it. There. Hopefully that now will work and give us a clear and a full clear. So let's give this a preliminary test out. So is the controls that we want to be testing. So first of all, let's do a full clear. and everything should go to 0. It has, apart from that. Now then, why has that not cleared? Because we haven't connected through to clear. Our full clear. Let's stop simulating. Check where our full clear goes to. I connected through to that one. What I didn't do is I forgot to put in the wire to connect through to this one. Now I've got to make sure I've got the right wire here, and it's the second wire down. This is such a sneaky thing. I'm looking at that carefully. I'm fairly sure that that's right. Let's save. So back to simulating. Lots of things have been set to 1 because we expect that. Let's do a full clear. Everything should be set to 0. Right, if we press, and that should have set our latch because it's part of the the reset is part of that. So that is high coming out of here. So when we click run, it should sequence through. What should happen though is it should fetch 0 and then stop. So let's see if this happens. And it has done. It's fetched the 0 command, which has then caused it to stop. And the halt line is high, which has set that down. Okay, so let's use manual data entry to put one command in here, and let's just put a number into our A register and see if we can make that happen. So the command for that is 1101, and then we put in the data what we want to have. So the command is 1101. The address is going to be zeros, and then the number that we're going to put in is 1010. Why not? This is kind of a default number that I tend to use for things. So we want to be in manual entry mode. Write that to the data memory. We're going to write that to the op memory, and then take that off. This is the first test that we're doing of this. So I'm going to hit reset. So what reset shouldn't do is it should reset everything except for those memory banks. Okay. We've still got that in the memory there. We've still got 1010 in that memory. That's fine. It's actually going to go through the process of fetching those, and hopefully the end result is going to be that this number 1010 will go into data, this number 1101 will go into op, and then it will move that into from data to A. Let's see if that happens. This is such an important moment. Here we go, fetch. Excellent. We didn't do a reset. Maybe we should have done a reset. It's stopped. No, it hasn't. It's still going. Now it's stopped. And so it's fine that op and data are now 0 because it's on the second line in our program, which is 000, which has made it stop. But we do have in A, we've got 1010, and it's working. Hallelujah! This is amazing. So we have what seems to be a working 4-bit CPU. This is quite a monumental moment in this. What I'm going to do now is I'm going to stop this video, and in the next video, I'm going to go through the process of checking all of these opcodes. I'm going to create some programs and manually enter them in and run them and see if we can actually make these things work. This is incredible, but that's it from me for now.